morning, students. As we have discussed in yesterday's class about formation of mirrors in desert, so today we'll discuss about optical fiber and sparkling of diamond. In case of diamond, sparkling cases, how total interreflection takes place. So let us discuss about the optical fiber. Optical fiber, you kindly note it down. That is, we'll see in this lecture how total internal reflection is related to the optical fiber. As you know that for total internal reflection, light should be traveling from denser medium to rarer medium. Second thing, the angle of incidence should be greater than critical angle. So in this case, the optical fiber, if I draw an optical fiber, it will be like that. Suppose it is an optical fiber. Couple of things to know about optical fiber. I hope you know in what purposes these are used. Optical fiber will have two layers like that. This is your outside layer and here will be your inside layer. Like that we can represent an optical fiber. Suppose it is an optical fiber, we have represent. In this case, you'll find that this outer layer will be known as this cladding. Remember, most important word, that is our cladding. And this inner layer, this is your core. Am I clear? So the outer layer, you can see this outer layer of optical fiber will be known as cladding, and the inner layer will be known as your core. So in this case, if I consider that refractive index of inner medium or inner layer, that is the core, is supposed to be mu1, and the outer layer refractive index is your mu2. That means in this case I will consider that mu1 will be greater than mu2. If mu1 is greater than mu2, obviously this particular layer will be denser with respect to this medium. Am I clear? So here mu1 is denser with respect to the mu2. So this is cladding and this is your core. And mu1 is the refractive index of core and mu2 is the refractive index of cladding. That is the component of an optical fiber. So in this case, as mu1 is going to denser than mu2, so if I consider, suppose you are now ready to send a signal, or if I close this particular side, like that I have closed it. So if you want to send some signal through this particular wire, so how total internal reflection will affect this optical fiber, you see. So if I send a signal like that, if a signal has been incident or like that, as you can see, the like that a signal has been sent. As this is sent by this particular way, that means what will happen? This signal will be traveling from denser medium to rarer medium. Am I clear? As it is denser medium, it is your rarer medium. So it is traveling from denser to rarer medium. So as you all know that once it travels from denser to rarer medium, that in this particular point, angle of incidence will be greater than critical angle. In this particular point, this is angle of incidence, and this angle of incidence will be greater than critical angle. So once angle of incidence becomes greater than critical angle, what will be the outcome? As an outcome, we will find the total internal reflection like that. Is that clear? So like that, there will be total internal reflection and it will move like this way. So again, similar things will happen here also. This is the normal. If I draw, in this case again, angle of incidence will become greater than total critical angle. So similarly again, this ray will get total internal reflection. Same thing will happen here also, and it will keep happening for multiple numbers of time. and at a particular point it will coming out from the optical fiber. So if I make a normal here, it will be very easy to understand for you. Am I clear? And at a particular time it will be coming out. Understand that? So like that, total internal reflection will take place inside the optical fiber. If you send the image signals, suppose you have sent some alpha signals from here, and as an outcome you will get the alpha signal. There is no loss of signal, there is no loss of energy inside the optical fiber, and that is how total internal reflection takes place inside the optical fiber. And as you know, as it's traveling from denser to rarer, remember, it is traveling from denser to rarer medium, and then angle of incidence become greater than critical angle. And that is how, no matter if you send to thousands miles away from the source, you will find the exact and origin signal as you sent. But I have told you that there is no loss of energy or there is no loss of anything in this case. So this is how the total internal reflection takes place in case of a optical fiber. So you should know the part of this is your core and this is cladding. The outer part is cladding and the inner part is your core. That is the optical fibers case in case of as an effect of total internal reflection. The next, if we see the next part is sparkling of diamond. As you know, the diamond is the most brilliant. It is got brilliant sparkling. It has got very sharp sparkling. You know, it is. If I consider like a diamond, suppose somewhere it is like a diamond, I have considered. Topic will be your sparkling of diamond. It is also an effect of total internal reflection. So in case of diamond, the total the critical angle of diamond, you can write the critical angle for diamond, in this case of diamond, is very less, and that is your 24 degree. Okay, 24 point something, 24.4 or something this degree. I have exact value should be 24.4 or it is like that. This value I'll correct in the next class. It may be 24.4 degree the diamond's critical angle. So it is very less. So once, that is why, since the critical angle is very less, so the angle of incidence become greater at any time. And that is how the total internal reflection take place in so many times. Multiple number of total internal reflection takes place inside the diamond. The result is that the angle of critical angle is very small. If I show you here, suppose that is how a ray is entering here in the diamond. So angle of incidence, then there will be what, like that. Again there will be critical. In this case there will be total internal reflection like that. If you make a normal here, suppose this is normal, understand now? Again similarly, again it will be total internal reflection, again it will be, there is multiple number of total internal reflection, like that it will take place. So as you can see in this case, the angle of incidence, in this case angle of incidence will be greater than critical angle for so many time. That is how there will be a multiple number of total internal reflection. And that is how it sparks very highly. Am I clear? And at a certain particular point, what will happen? Angle of incidence will be less than 24.4 degree. Once the angle of incidence will become less than 24.4 degree, then it will be refract. You have got the point? Until and unless the critical angle is remain less than angle of incidence. Am I clear? So if you know this situation, that angle of incidence should be what? Greater than critical angle. But in case of diamond, as the critical angle is very less, 24.4 degree, so angle of incidence remain bigger than the critical angle. But at a certain time, angle of incidence become less than critical angle. Once angle of incidence become less than critical angles, then this particular ray refracts. Am I clear? And then only you can see the sparkling, bright sparkling of diamond. And this happens due to total internal reflection. So these are sparkling like the devil spark. Have you got this? I got the point. In case of diamond, the critical angle is something about 24.4 degree or say 24 degree. You can I will confirm it. I forget this value. So 24.4 degree is the critical angle, which is very less. That is, once the ray of light enters, the multiple total internal reflection take place inside the diamond. And once angle of incidence become lesser than critical angle, then the ray somehow refract out, and then you can see a bright sparkling or smart sparkling of diamond. This all happens due to the total internal reflection. One more thing you'll find very interesting, that is our prism. In case of prism also we can find the total internal reflection. The total, you write down total internal reflection in prism. So in prism also we can find prism. How we can find total internal reflection in prism, I'll show you. You know what is prism. In case of prism, in case of glass, the critical angle is 42 degree, remember. So if I consider a prism like that, you have seen prism in the laboratory. Suppose it is a prism I have considered. This is a prism, suppose, and this angle supposed to be 90 degree, this angle is 90 degree, and rest of the angles will be 45 degree. This is 45 degree, this is 45 degree. If I consider this is a prism, and we will see now how total internal reflection takes place inside the prism. So if I consider a ray of light is incident normally to the prism, so it will go as it is, there will be no deviation, undeviated. That means if a ray of light is incident on a surface at 90 degrees, so it goes undeviated no matter it is going from denser medium to rare medium or rare medium to denser medium. But if you consider this will be your glass medium, so this will be your denser medium, and outside medium will be your rare medium as it is air. So in this case, if it once it is entering to the glass medium, so what is happening? It is traveling from what? Denser to, this is denser medium, this is denser medium, and this is your rare medium. So once it is traveling from denser to rare medium, so in this case what happens? It will go this way, since there will be some total internal reflection. If I see here the normal, if I make a normal here, this angle, this will be angle of incidence, and this angle of incidence will be greater than, this angle of incidence will be greater than what? Critical angle, 42 degree. What is 42 degree? The critical angle of this glass you can consider as it is 42 degree, remember. Am I clear? Critical angle of this prism will be 42 degrees. So once this ray is coming, entering here at 90 degrees, so it will undeviated, but before being refracted, this is denser medium, this is rare medium, it will be reflected. Why? How it will be reflected? Because if I make the normal here, this will be angle of incidence, this angle of incidence will be 45 degree. Am I clear? So if this is angle of incidence is 45 degree, so angle of incidence 45 degree will be greater than the critical angle. Since we know the critical angle of glass medium will be 42 degree, so 45 degree will be more greater than 42 degree, hence it will reflect back as the total, this way, and this is total internal reflection. If I consider one more ray, suppose I am taking one more ray like that, this will also bending this way as a result of total internal reflection. So this is your normal, and this is your angle of incidence. This angle of incidence will also be 45 degree. Am I clear? So you know how it is 45 degree. So that is how the total internal reflection takes place in case of the prism. So if I take a prism in alternate way, if I take a prism, suppose I am taking prism like that, then what will happen? This is a prism, suppose this time I want to rotate it at 180 degree. As you can see here, the rotations of the angle is how much? 90 degree. But in case of these things, if I consider this angle is 45 degree, this angle is 45 degree, and this is suppose 90 degree. If I take a ray of light incident like that, suppose this is being incident this way, then what will happen? This will be the normal. As it normal, this is going to be your angle of incidence, which will also be 45 degree. So 45 degree will be greater than the critical angle of glass, 42 degree. So it will reflect like that. This direction will reflect, and in this case, if I make the angle of incidence, then it will also be 45 degree. So this will also be greater than 45 degree. Since it is greater than critical angle, so it will come out like this way. That is how. This is also be a one demonstration of total internal reflection in case of prism. Remember, the critical angle of glass or in prism we supposed to be 42 degree, and in case of the diamond is 24.4 degree or 24 degree. I will clear it. I forget about it. So that is how total internal reflection takes place in the prism. Same story, that critical angle should be, angle of incidence should be greater than critical angle. Those were the effects of total internal reflection. I hope you have understood. You will practice it. It's a very important topic for the final exam. In the next class we will come with a new topic. Till then you keep practicing. If any doubt, comment in the inbox. I'll try to get back to you. Thank you so much.